Hello there! This video is all about index numbers and inflation, which are based on index numbers. And index numbers are really designed to assess changes, and mostly we're looking at costs across time. So looking at time series data, but computing these index numbers to make more easily comparable values. And index numbers are really a way that we measure the pulse of the economy. So there's a lot of math involved with this, and I'm going to try to keep it as simple as possible here and just kind of do a brief overview. Although there's going to be some formulas when we're looking at comparing index numbers, once we get to looking at inflation, I'm going to show you a really cool online tool that's going to make it really quick and simple for you. And you'll be able to use it anytime you want to figure out inflation. So I'm going to start this lecture looking at simple index numbers, which are ways to evaluate changes across time for a single item. And then I'll briefly discuss some weighted aggregate index price values like the LASPEYRES, the PASH, and the Fisher index. And then I'll finally show you this really cool calculator online to assess inflation and sometimes deflation if costs are decreasing. So index numbers are all about using historical time series data to accurately compare monetary values across time. They really allow for easy, quick comparisons by identifying a base year and scaling all the other results off that year. Index numbers are used to kind of feel the pulse of the economy, and they reveal tendencies regarding inflation and deflation. Index numbers are described as barometers of economic activity and are used to monitor or compare things like the cost of living, industrial production, agricultural production, and business activity over time. And oftentimes, these comparisons are made on a yearly basis. Simple index numbers are used to compare costs or profits for a single item over time, so like sales history, price of gas, training costs. Although you will be presented with several formulas in a moment, these are only emphasized to help you understand how to compare index numbers and compute raw values associated with index numbers. So sometimes, actually most times, the raw values aren't provided. All you have are the index numbers, so I want to show you how to make sense of that with just that information. So again, simple index numbers are just fluctuations in a single monetary variable that are compared to a base period index, or in other words, the reference point for all index numbers. So before constructing an index number, it's necessary to define precisely the purpose for which they're going to be constructed. So a single index cannot fulfill all the purposes. Index numbers are really specialized tools which are more efficient and useful when properly used. So if the purpose isn't clear, the data used may be unsuitable and the indices obtained may be pretty misleading. So for example, if you want to construct a cost of living index, you cannot use a simple index number because simple index numbers only examine one item at a time. The cost of living is based on many factors that are consumed at different quantities, so a weighted aggregate price index would be more appropriate. You also need to carefully consider the base period, or that reference point for all simple index numbers. The base period could be meaningful, so for instance, when the market crashed or when the company started, or these base periods could be based on convenience, so the earliest point that data is available. In general, it's best to have a base period that is somewhat recent and based on a normal time. So for instance, you wouldn't want to base retail sales on a base period that was at Christmas time because that's going to be an excessively busy time. It's not really a normal time period. So here are some formulas for comparing simple index numbers, and I'm going to demonstrate these here in a little bit so that they make sense, but I just want to provide them all right here in case you ever need to do this on your own. You can refer back to this slide. So let's take a look at that first formula that you saw in the previous slide, which is used to calculate a simple index number. So what you do is you take the value at the time of interest, divide it by the value at the base period, and then multiply it by 100. So if you see here, the value, our base period is 2004. So that's our base. And that is the frame of reference for all of these index numbers, as I'll show you here in a sec. So if we look at this, for 2004, it's going to be 100 because these two values are the same times 100. So whenever you're looking at index numbers, specifically simple index numbers and many others as well, the index number for the base period is always 100. That's like your starting point. That's a nice, easy number to work with. Now, if we look at the next one here, you can see that the price of gas was $2.60 in 2005. So that's going to be the numerator here. That's your value at the time of interest. And then you divide that by the price at the base period and multiply by 100. And that's how you end up with this 136.8. So you see that pan out for all the following values, right? Even if we go down here, looking at 2011, the cost of gas was $3.60 in 2011. Take that, divide by the cost at the base period, multiply by 100, and this tells you that the cost of gas in 2011 was 189.5% of the cost of gas in 2004. Or in other words, the cost of gas was 89.5% higher in 2011 than it was in 2004. Now, in the previous slide, the actual prices of gas were presented to you. But in most cases, index numbers are presented without the values used to calculate them. So it's important for you to be able to interpret index numbers alone. So if you look here, right, gas prices in 2005 were 36.8% more than in 2004. Remember, the simple index for the base period is 100. So if you want to find the change, you just subtract the index number for the year of interest by 100. Based on these index numbers, you can also see that gas was cheaper in 2009 than gas prices in all other years, because 131.6 is lower than all of these other numbers. You can also see that gas prices in 2009 were 31.6% more than they were in 2004. So it's important to note that sometimes you want to know the rate of change for 1 year compared to something that's not in the base period. So if you want to assess the rate of change between two time periods and one of those time periods is not the base period, then you need to use this formula right here. Ooh, that was squeaky. So what you do is you take the later index, subtract the earlier index, divide by the earlier index, and then multiply by 100. So for instance, if we were wanting to know the rate of change between 2008 and 2013, we are looking at these two values here. And so this is going to be the earlier index, and this is going to be the later index. So you can see where those values in this formula are coming from. So if you do the math here, you'll see that there was a 10.5% decrease in gas prices from 2008 to 2013. Now let me show you another example. So now let's say we want to know the rate of change in gas prices in 2014 compared to 2008. So as before we were comparing 2008 to 2013, now we're comparing 2008 to 2014. And again, we have a situation where neither one of these years is the base period, which happens to be 2004. So again, you would take the later index, so for 2014, and you would subtract the earlier index, so 2008, then divide by the earlier index from 2008, multiply by 100, and you get this value right here. So you could actually see that there was a 3.4 decrease in gas prices from 2008 to 2014. And you know it's a decrease because you see a negative number here. This is also a decrease because you see a negative here. And it makes sense that prices are decreasing over time because if you look at this table, in 2008, we have the highest index number. So across 2004 to 2014, gas was most expensive in 2008. So if you compare 2008 to any other time period here, you're going to see a decrease in that price. So I've shown you how to assess the rate of change, but maybe you actually want to look at differences in monetary values based on simple index numbers. So if you look at this, let's say we don't have all the values here, but let's say we do know that the mean gas price in 2004 was $1.90. So if we look at this table, we know that gas prices in 2008 were 200% of gas prices in 2004. So we could ask ourselves, well, how much more is this? So to do that, to figure out the rate of change, you take the index number for the time period of interest, which is 200, because our time period of interest is 2008, and you subtract 100, and you know it's 100% more. And I've kind of already shown you this in the past. But more than that, we want to look at, okay, we know that it increased by 100%, so how much more does gas cost in 2008 compared to 2004? Now this math is pretty easy because we're working with 100%, but I'm going to show you this formula anyway because you don't always have such clean numbers. So to do this, you're going to look at that value change formula on the previous slide that I showed you where all the formulas were. So for this one, you take the index for the time period of interest, or in this case, 200, and you subtract 100, and then you divide by 100, and then you multiply whatever you get in that parenthesis by the base value, which in this case is $1.90. So if we look at this, we have 200 minus 100 divided by 100, and that gives you 1. And then you multiply that by 190, and gas was $1.90 more in 2008 than it was in 2004. Now we want to figure out what the value is. So we know that gas is $1.90 more now than it was then. So you could technically just add this $1.90 to this $1.90, and you'd end up with $3.80. But sometimes when you go to do this, you may not want to go through this process of first finding out the value change and then finding out the actual value. So in that case, if you're just asked what is the price difference, then you can jump straight to this formula and figure it out. So for this, you take the value at the base period, or $1.90, and you multiply that by the index number for the time period of interest divided by 100. So if we're looking at 2008, 200 is our index number for the time period of interest. So you take 200 divided by 100 to get 2, and we know that gas was 190 times 2 in 2008, or $3.80. So now let's shift our focus to a situation where we're not just looking at a single item. We want to assess fluctuations in the price for multiple items across time. Now I'm going to start with just aggregate price index and a really quick overview of that, but then we'll focus more on the weighted aggregate price index numbers that not only control for changes in the price, but also changes in quantities across time. So this is the most basic version of an aggregate price index, and this is basically where you just add up the values of everything you want to look at, the time period of interest, and then you divide by the values all added up at the base period, and then multiply that by 100. Now this is really an uncommon type of index because typically you don't have the exact same consumption rates of all the items that you're looking at across time. A classic example where you could use an aggregate price index would be like the cost of going to college, assuming that you're buying the same number of books because you're taking the same number of classes. So your tuition, your credit hours wouldn't change, but the price probably would. And although you're not buying any different number of books, the cost of those books may change. So this formula is only appropriate when you want to look at changes in the cost of multiple items, but you're not changing your level of consumption or how many of those items you're buying over time. So a much more common type of index is a weighted aggregate price index. So this is where you can examine prices of groups of items across time based on differences in both price and quantity. So the most popular weighted aggregate price index is the consumer price index. And this is really looking at the cost of living based on changes in cost and consumption of goods. But you can also use weighted aggregate price index numbers to look at changes in interest rates based on different types of loans that are more or less frequent over time, payroll changes based on percentage of workforce in each position and respective pay, and a whole host of different things. So one type of weighted aggregate price index is the LASPEYRES index. And this is where prices are based on base period level, weight, or quantity of usage or consumption. So we're basing those changes in consumption on the base period. Now this really helps give us an idea of what yesterday's basket, right? The basket just refers to all the goods that are being used to compute this index. So it gives you an idea of what yesterday's basket will cost at today's prices. A LASPEYRES index of 1 means that the price of the basket or the bundle of items in the base period is equivalent to the time of interest. So in other words, if you had a LASPEYRES index of 1, that means that you can afford the same bundle of goods now that you could at the base period, maintaining the same budget. And so this would also tell you how much do you need to increase income to offset inflation. So if you have an index number that's above 100, that's going to give you roughly an idea of how much more money you would need to maintain the same budget for the same quantity of items that you had in the base period. Now, because the LASPEYRES index uses base period quantities, it tends to overestimate inflation by assuming that prices are still distributed in the same way. In other words, the LASPEYRES index does not take into account fluctuations in quantity. Because think about it, as prices increase, people are going to spend less. They're going to buy more of those items. So it doesn't control for these things called substitution effects. Think about it too. The inflation of the item with the highest quantity in the base period is going to have the most impact on the index. However, the item with the most inflation will likely have a quantity that changes the most over time. Because again, if it costs more, you're going to buy less. So another type of weighted aggregate price index is the PASH index. And this is where your prices are based on the current level of usage. So LASPEYRES is based on the base period level of usage, and PASH is based on the current level of usage. So this helps you get an idea of what today's basket would have cost at yesterday's prices. Now, given that we will not likely go back in time, the PASH index is not as easy to interpret and actually not quite as useful as the LASPEYRES index. Now, a PASH index of 1 would mean that the price of the bundle of items in the time of interest is equivalent to the base period. Or in other words, if the PASH index is 1, you can afford the same bundle of goods in the base period as you can now. Now, because the PASH index uses current period quantities, it tends to underestimate the inflation by assuming that prices are still distributed in the same way. And it already really reflects some of the changes in consumption patterns that occur when consumers respond to price indexes. So for instance, if there's an increased consumption of goods, that's going to indicate reduced relative prices. Now, finally, the Fisher index. So this is kind of like a happy medium between the LASPEYRES and the PASH. So we know the LASPEYRES index overestimates inflation and the PASH index underestimates inflation. So the Fisher index combines the over and under estimates of inflation to find a middle ground that's an accurate measure of inflation. So as such, the Fisher index is typically used to assess inflation and deflation because it controls for the over and under estimates that the PASH and the LASPEYRES index provide. Whew, that was a lot of information. So given that published consumer price index figures for most countries are usually described as having been calculated using a LASPEYRES index, I'm only going to show an example of the LASPEYRES index. So I'm not really going to focus on the PASH or the Fisher index. Also, keep in mind that the actual calculation of the consumer price index could differ due to the base period, price, and the quantity, or the expenditure data that's being recorded at slightly different times. So just keep that in mind. Kind of take these consumer price index values with a grain of salt. Now, although I'm not going to demonstrate the computations for determining all these beautiful index numbers, I want you to keep in mind that these are based on base period level of usage. I'm not going to show the calculations because you'll probably never do this in the real world. You'll probably need to interpret index numbers but not actually compute them. So since the LASPEYRES index is based on base period levels of usage, what we could ask ourselves with these numbers is, if I was consuming what I did then, how much money would I need now to maintain the same budget? So based on this table, we know that the cost of gas, food, and electricity in 2018 is 142% or 42% more than the cost was in 2004. So in 2018, you would need to make 42% more to keep the same budget for gas, food, and electricity. So you'll see that the LASPEYRES index works pretty much the same as the simple index numbers. Getting to these values is much different, but the interpretation of the values is pretty much the same. These are all based on the base period of 2004, and each of these values, kind of if you subtract 100 from it, will tell you the rate of change from the base period. But if you don't want to make comparisons with the base period involved, you can use those same formulas that I showed you for simple index numbers. I'm only going to demonstrate a couple because I already showed you how to do those with simple index numbers. So now you can see how to use the formula again to look at the rate of change from 2008 to 2014. Neither one of those years is 2004, so we have to use this formula here to look at the rate of change. So if you think about this, we are looking at 2008 is going to be our earlier index, and 2014 is our later index. So you plug those values into the formula and you get 6.5. And what this tells you is if your income did not increase by at least 6.5% between 2008 and 2014, your income failed to keep up with the inflation of gas, food, and electricity. Here's another example. So now let's compare 2014 and 2018. So now our later index is the 2018 index, and so that's our later index. Let's do some color coding here. Let's spice it up. The earlier index is going to be from 2014 right here. So you'll see where those values are coming from in the formula. So if we do the math there, we can see that if your income did not increase by at least 5.2% between 2014 and 2018, your income failed to keep up with the inflation of gas, food, and electricity. So your budget would be different. Now let's shift our focus to inflation and deflation. So the object of controlling for inflation and deflation is to remove any part of the variable's change that's attributable to price movements. So you could arrive at a real or inflation/deflation adjusted indicator. So for instance, $20 will buy less retail output today than it did 20 years ago. But for data collectors, a $20 purchase gets added to total sales in the same manner today as it did 20 years ago, even though it represents a different quantity of goods. So inflation occurs when the price of goods and services rise, while deflation occurs when those prices decrease. Inflation is caused when goods and services are in high demand, thus creating a drop in availability, and when consumers are willing to pay more for the items they want, and this causes manufacturers and service providers to charge more. Deflation occurs when too many goods are available, or when there's not enough money circulating to purchase those goods. For instance, if a particular type of car becomes highly popular, other manufacturers are going to start making similar vehicles to compete. So soon, car companies have more of that vehicle than they can sell, so they must drop the price to sell those cars. When credit providers detect a decrease in prices, they often reduce the amount of credit they offer, and this creates a credit crunch where consumers cannot access loans to make big item purchases. And this leaves companies with overstocked inventory and leading to further deflation. So deflation can be problematic. It can lead to an economic recession or depression, and the central banks usually work to stop deflation as soon as it begins. So while calculations for inflation and deflation are typically based on the Fisher index or the LASPEYRES index that usually drives the consumer price index, I'm not going to focus on calculations because there's many tools available online to calculate inflation or deflation if the cost of living decreased over time. So typically inflation happens as time progresses, so you can enter an earlier date to compare to a more recent date in an inflation calculator to determine how much money you would need in the more recent time period to keep up with inflation since the earlier time period. So now let's use the inflation calculator to figure out how much Dean would need to make in 2017 to maintain the same budget and keep up with the cost of living, based on the fact that he's been receiving a fixed income of $18,000 since 2004. So to do this, you're going to first, if in 2004, I purchased an item for, and we'll just put the whole salary in there, 1,000. Then in 2017, you would need $23,320.24 to have the same buying power that you had with $18,000 in 2004. So if you think about it, Dean has, what's the difference between those two numbers? 5,320. He has $5,320 less of spending power now than he did in 2004. It's kind of troubling. Now this example is going to do the inverse of what we did previously, where we entered an earlier date first and then a later date second. So think about it. Typically, costs were lower in the past. So if you want to have a situation where you are looking at your sales across time, but you want to control for inflation, then you can enter a recent starting date first to compare to a time in the past in an inflation calculator to then adjust those values based on a base period, or for example, in this case, when the company started. So in this example, AD owns and operates a small medical cannabis dispensary in California, and she wants to prepare a presentation for investors, and she really wants to show off how much her sales have increased over the last 10 years. But she doesn't want to overstate this. She wants to control for inflation because it's probably likely that the actual increase in sales is less magnitude if you control for the fact that the cost of living and the cost of running a business has increased since 2007. So now let's use this inflation calculator to control for the fact that inflation has probably led to increased values over time and to adjust 80's sales to the value that they would have been in 2007. So for all of these, we're going to have 2007 right here, and then we're going to have the actual date of interest or the year of interest, and then the sales figure for that year here. So just to demonstrate how I got the values in this table, we're going to say, all right, 2008, and the sales in 2008 were $59,005, and that's where that $56,823 comes from. So it's not as impressive once you control for the fact that inflation probably occurred and you adjust it back to the 2007 value. Let's do another one. So in 2009, her sales were $59,000. Again, 305. Now check this out. This is interesting. Remember, there was a recession in 2008. So between 2008 and 2009, there's actually deflation happening there. So if we look at those values, although the sales were the exact same, when you adjust them, they're actually a little bit higher in 2009 than they were in 2008, again, because of the deflation and the recession. Let's do the next one. 2010, AD pulled in $62,500. Let's calculate that. Adjusted to 2007 rates, we see that would actually be $59,429 if we're really controlling for the inflation. So that shows you how I got all those values in the table. I'll do one more just so you can kind of see how it works out. 2011, and she pulled in $70,500, and there's our adjusted value to $2,007. So finally, just to give you a quick visual of the difference between raw sales and sales that you're controlling for inflation, you can see that overall, there is an increase in sales, right? Regardless of how you look at it, but it's a little less impressive when you look at the adjusted sales instead of just the raw sales.